Okay, it's
Oh, yeah, I
recording.
see.
And I pause.
Today, we're going to have a workshop presented by Marek Sadowski. It's going to be more about an introduction of Red Hat OpenShift, how can you deploy it on IBM Cloud, how to deploy applications on and with OpenShift, and so on. If you have questions, just please free to ask in the chat. And if you want to join to the Slack group from Women Who Code, just please send me a message in the chat and with your email, and I will send you the invitation. Other than that, Marek is ready to present.
All right. Thank you so much for having me, first of all, and and I am second time joining the webinar to Women Who Code worldwide. I did it last summer, I think, if I recollect correctly. So I will try to share my screen if it's okay with everybody. So let me just get there, sharing the screen and going to the presentation. So so I hope everybody sees my screen. Today we will talk about Kubernetes with Red Hat OpenShift, and it's a workshop, it's hands-on. So if you guys want to join and do coding with me, you are more than welcome. I will do a little bit of introduction, so a little bit of the theory, and then we'll go to real examples. So we will do 2 labs together. So first lab will be about the Docker, and the second lab would be will be about using Kubernetes in OpenShift environments. I will explain what are the differences, and so after this workshop, I hope you guys will understand why we are using Kubernetes, why we are using Docker, what's hot about using containers at all. So we will start with that. So without further ado, let me introduce myself. So I'm Marek Sadowski. 20 years ago, I was in NASA working on a Mars mission. We were doing virtual reality systems to manage robots. I couldn't find my job in robotics, so I started to work with the large companies. I was consulting IT projects across the world. But in 2004, I started a pet project with robots, and eventually I met my business angel and I launched my own startup. With my startup, I moved to Silicon Valley, and my wife said, "Your startup doesn't bring enough income, so find yourself a proper job." So I rejoined IBM, and I'm learning a lot about AI. I'm very fortunate to work with the latest technologies, so blockchain, even quantum, and AI, and I'm still kind of overseeing what my startup is doing. So I'm trying to push the needle over there from time to time. But because of working for IBM, I'm so super fortunate that I have free time for my family. I'm having 2 kids. We are all in lockdown now, so a little bit we are depressed, and because of that, I'm also very happy to be with you today and seeing people and talking with you. So I'm super happy about that. In my free time, I'm a rescue scuba diver. So if you have any problem under the water, I'm the one who would probably try to get you to the surface. I'm also a snowboarder. Here I'm based in Silicon Valley, so we have very, very close. We have Tahoe, Lake Tahoe, and there is a nice side of the Sierras where you can snowboard or ski. I'm also doing martial arts. It's a lot of workout, and but it keeps me straight, and I feel a lot of energized, and I feel good because I had some problems when I was spending too much time in front of the computer. So today, some of you were asking what are we going to learn. So we are going to go over containers. I will go over Docker, Kubernetes, origin distribution of Kubernetes. So we'll talk about OpenShift, and we'll do some workshops. Then we do wrap up. And as Paola was saying, there's also Slack channel, and that we can use. So one of the things I have requested in the very beginning, please join us on the and sign up for IBM Cloud. We will use it in the first lab. So you can start to do it now with this first link. So ibm.b/www.sf-2020-03. And then we'll go through the through some of the labs. So how we got here, and let me see. I don't see the chat now. I will go to the chat after the presentation, before the first lab. So it's in 10-15 minutes. Entire workshop today is going to last about 1 hour. So now it's over here it's 6:38. So we'll finish in 1 hour more or less. So we started with bare metal early 2000, and people were putting entire applications on the bare metal, so on the servers. So you had to really SSH or telnet to the server, and then install all the resources, install your hardware, and eventually start your program. It was taking a lot of resources in terms of the team involved. So people that were responsible for providing you or providing the developers with the storage, all the libraries to connect with other infrastructure, and providing, for example, your application servers and the patches to operating systems. So there are a lot of jobs involved to run bare metal environment. After some time, we started to use virtual machines, and virtual machines abstracted away the hardware. So now you would just install your operating system, and on top of operating system, you would just install other things, but you wouldn't look into the hardware. Hardware would be provided virtually to you. So that was one step to the easier operations and more agile approach to run systems. But still, they were solid, like a very large systems that would so-called monoliths. They would be very, very large. And just recently, we started to talk more or less year 2013 about containers. So containers started to come into this space when we moved away from SOA deployment, so service-oriented deployments, into the world of microservices. And microservices were based on containers. So containers, small applications that would respond to some request. And we will do one example today. And then we would move to the next step, functions. So functions are serverless operations that you even drop away the containers. And step between virtual machines and containers was to drop operating systems. So you'd only have applications to install on top of some virtual libraries and system libraries or libraries for the given application server. Functions, though, they are just simple functions, simple operations, very atomic ones, and you can run them, and you don't care about the system that is provided for you. It's done by vendor. And what are the differences between virtual machines and containers? So virtual machine would be, as I said, would abstract away through hypervisor the hardware. So you would have to, when you use virtual machine, you have to install your operating system, and operating system needs to have all the patches. So you have to always update the patches for operating system. Otherwise, your machine might be hijacked by some hacker, or or hacking babies. They call them like this because they are just using the scripts and they run the scripts. They can exchange the scripts in a dark web, and they would attack they will attack everything that we call it moves around you in the internet. So you have to patch your operating system, then you install your libraries, you install your application server, and finally your application. So you have to get people responsible for one, operating system, two, people responsible for application servers, and three, developers who build your business logic. What happened with the containers, we abstracted away operating system. So we don't have operating system at all in container most of the time. You just build your basic application, and you have some libraries and binaries that you would use in your application server and your app. So so you don't think about applications, operating system, and your application is just running there. So so you would install, for example, Node, so JavaScript operating system or Java operating system. So you would download entire container using just for example, Open Liberty, which is the remains of the Web3 application server from years 2000, if you are familiar with Java, or you would get the Torch for Python and so on. And with that, one of the things that is happening, you can really squeeze your container to be very small. And because it's very small, now you can, instead of having like a lot of space taken by the operating system, now you can really launch a lot of these containers in the system. So so what is the Docker mission, and why Docker? So Docker was one of the most used systems because, and it was picking up a lot of traction because it was open source, it was very easy to use, and it had just a very simple message and mission to build your image, then ship it to someone as a container, and then run it anywhere. And you have a lot of systems that you can run it. You can run it on your desktop. Today we are going to do it. Then you can run it in the cloud, and any cloud, and then it's a great way to work. And there are a lot of applications, a lot of systems that we are using today. We are going to use Node, so we are going to download the Node-based system. So if you see this table over here, it is one of the systems that you can use. You can of course download the operating system as well, but you can just run applications, and this is the basic thing that you would do. The other thing that is very important about containers is that now you kind of bring together two concerns together. One is development, the other is operations, and you bring them together. So if you are a developer, you are responsible for code. If you are in operations, you are responsible for logging. And these two things, these two worlds are coming together, and we created a new role, Devops Engineer. So somebody who is agile enough to understand both a little bit of the development, knows how to manage the container from, let's say, from Python or Java, and also understands the networking configuration, monitoring aspects, and so on. So they can kind of grab it together and create a pipeline for moving this container from development, from GitHub, for example, to production and to orchestration of containers. So in a moment, if you haven't downloaded your Docker, that's the last moment to do it. But you are going to use Docker in a second. So when you install Docker on your local machine or on your server in the cloud, or your vendor is providing the Docker environment for you, either through Kubernetes clusters or through other ways, you would see it as such environment. So you would have a Docker engine which host all the containers. You have your base operating system. So in my case, it's macOS, so Macintosh operating system. Maybe you are using Windows, maybe it's on Linux, and that's our environment at the moment. And when you bring the images, either you create an image or you use the images that are being created by some other people and provided for you through repository, so or registry. And you have Docker registry that is called Docker Hub, or some companies are providing you with the managed registries that provide you with the private registry. So nobody's going to see your secret source, which are your secret images, and then you can build your application based on this environment. When you want to access your Docker engine, you would use client, and there are various clients, but one of the clients we are going to use is CLI, so command line interface in your terminal. So we would run commands like docker run, docker build, and we'll do docker images, we'll run docker container stop, and so on. So these are the commands we are going to use, and they are from command line interface. And also when you expose your container, you say which ports we are going to use, and this is what we are going to see as well. So now we will start our lab, and we will use, as I said before, you have to get your cloud account. Use this link. It gives me brownie points if you use it. You can also omit this brownie point if you don't like me too much. But it will give us information that you use it. So let me just, I think we have copied it over, and we will use our Git book. So this one, let me see if it opens for us. So I will just click here. Yeah, it opens the workshop. So let me go to. I will stop sharing for the second. I will check I will check our. So I will give you this link over here in the chat, and I will check if we have any questions. So Afia needs help with installing the Docker. So one of the things that you will notice through this link I just provided to you. Let me just share the screen again. Before I share, I will let me just try to manage all our participants. I will mute everybody, so sorry for that if you were, but you can unmute yourself when you have questions and you are bothered with something really tough. So I'm because I'm hearing a lot of messages coming, so I don't want to hear that. And I will remove the chime for when you come in or come out. So I just removed that. Let me share the screen, and let me share my screen again. So this is the view you would see when you open this link I shared with you that is studying this Red Hat OpenShift workshop. And the first step I shared with you, so this is the link you would have. When you sign up, you would get, you have to fill out the form. You just share it's free light account. So it should be forever free, we hope. So you would get the information, okay, you completed your registration, and get then, you will get an email, and you have to respond, you have to activate your account. So somebody is asking the question, let me see, chat. Okay, yeah, so this is the kind of first step. So now when your setup is activated, your account is activated, you will be able to use one of the things over here. So now we will do lab one, and I have a little bit of the explanation over here saying what we are going to use. We are going to use two things. So our lab is going to provide you with the access to cloud, and we will draw results of the translation service. So we will use the Watson translation service from the cloud in our application. It's going to be, everything is going to be free of charge, and you can use it outside of our workshop, and I will show you how to do it. It's a little bit of the explanation how Docker is run. So this repetition of what I have done. There are also steps, and we are going to use again this our environment. So first we need to get the language translation service. There are steps over here, and you will look for the translator, and you will come up with the translator language translator service. You would create the service, and you would copy the credentials for later. And I'm going to show it how it's being done now, so you can also do it together with me. So when you sign up to IBM Cloud, and I have a light account like yourself, you can use left over here on the left-hand side. I have a small, we call it hamburger, so it's a menu. And over here you have dashboard. So whenever you have any challenge, you want to return to the common place, that's the place to come. On the dashboard, just to give you an idea, there are a couple of things that you want to do. One thing is that this is your account, so Marek Think account. Then you might have also other accounts. We will use it later on if we will assign you with additional account from IBM to use the images and environment. But one of the things over here is a catalog. So dashboard catalog is to look for the new services if you want them. Over here you have overview of the systems. There are some situation in the locations, so you can see what is the status of the cloud in various geos. So you can kind of use it. Over here we have information about your Cloud Foundry application and Cloud Foundry services. So these are the resource list that is active. I have some applications over here. I have some services. As you see, I have a couple of services. I have Watson Assistant, which is the chatbot backend, visual recognition, some text to speech, speech to text, so voice services, and I think that's it. It's very thin account. I have some application running here, but that's all. So once more, I'm getting back to the dashboard. So this is what happens when you log into to IBM Cloud. Now, if I go to catalog, there are 180 services. Most of them, they are available for you in a light mode over here. And there are a couple that are restricted for, they are also for free, but they are restricted and you have to sign up with your credit card. And I will give you an explanation later when we start to do exercises, but let's see what we have for free. So we have, for example, AI services, and out of those AI services, there are like 18 of those or something. We will use this language translator. I'm also delivering course and showing how you can use visual recognition. That's also a nice service to have. And I mentioned before Watson Assistant, which is the nice course, nice system for the chatbot. But we are going to use, as I said, language translator. The other way to do it or access it is to just type here translator. And you don't need to even select it because it just goes to filters everything. So I just click on the service, and it will bring you the environment. So one of the things to notice, you don't want today, if you are based in States, unless you are based in UK or Europe, maybe you want to use your local environment. I'm based in US, so I want to use Dallas account, and I recommend you to do it. There will be some complications if you use different region, but it should be okay for us. So we have this Dallas region. The service is free, and you can translate 1 million characters per month, free of charge. So every month, 1 million characters. So for developers, it's pretty awesome. even if you're a startup, you can create your application and show it to the VCs and provide them with the free of charge prototype. And they would say, oh, that's great, the great environment. And you would do presentation like me today, and you would show them application. You would say everything works. It's a live system, hits the backend in a cloud, and it's HIPAA certified. So everything is super cool, and give us this seed money. So we can call this service whatever you want. There are some restrictions, but I will call it Women Who Code, and I will give it the date, so I will know that it's for today's service. And you can also give it a tag, so my Docker, and so it will have a tag, so you can kind of filter everything through tags. And as you see on the right hand side, before I create, I have estimation. It's free, so it's not going to charge me anything. So I'm creating. So now the service is being provisioned. There are a lot of services, as you have seen, and a lot of them are having a light account, light version, so they would be free of charge. And over here, this is showing us how much of the service is already being used, so 0% used. We need to click on the service credentials. So service credentials, we are going to create a new credential for us, just for this, for the need of this workshop. So Women Who Code credentials, and I'm leaving the manager, and I will auto-generate the credentials. So I'm adding these credentials. In a second, they are going to appear here, so I can watch them. I'm going to delete them, so if you copy them, it's not going to help you for long, just for the length of this this workshop. So I have API key. This is important for us, and we are going to use URL. So I'm going to copy this to my podcast file, and so just copy it over. So I have this element over here. I will need this guy later on, and I will need this guy later on. So these are elements that we will need from our service credentials later on. So we have created one service, and if you look at the dashboard again, let it open. If you look at the Cloud Foundry services, there is one service that is working over here, just regular service, is our language translator DAP code 2020-03-26. So we have our service, and you see I have also tags, so we can filter by tag, for example, so it might be useful for future. So that's all we have done in the cloud. So you have one service in the cloud. So now let's see what we need to do with our labs. So let me just move this window a little bit. So we have done this step. Let me increase the size so we can see it maybe better. So I'm moving now forward. So congratulations, we have created the language translator service, and now we can create an app. So now I'm going to open my my local environment, and so I need to go to the CD. So let me increase the size. Sorry for the small environment over here. I will increase it so you guys can see it. So I'm in my root directory. I will go to the desktop. It's easy to find, and I will make it over here, and I will call it DAP code and 2020-03-26 and web. And I will go to this DAP code 20 web. Okay, and we are here. So this is according to what we are asked to do. It asks us to change to the directory. I don't have this data directory, but we can create it. And so make data cd data. And now we have to clone this image. So one of the applications you need, it's a Git. If you don't have Git, there is also other way to do it. So let me show you what you can do otherwise. So one of the ways you can do it, you can just copy over this HTTP link without the Git. And you can open a window and just paste it here. It will open the repository for you. And over here you have clone or download. So just hit this and download zip, and then use it as we are using the directory. I'm not going to show it, but you just hit this and you can do it. If you don't have Git, if you have Git, you can easily download it as I have done it. So if you do ls, you will see this Docker Node.js language service. So I will cd docker, and then we have it. We are over here. So we have this list of the services, and now we are going to go with the Docker. So there is one thing that you should know. I have a Docker over here as well. You see. And I am signed in. You might not be signed into your Docker. When you install it, after installation, you are okay, but you have to sign in. So in order to sign in, I think I have put it in our lab how to do it. So if you want to use Docker command, you have to get your and use over here the Docker username. You have to really use the Docker hub, and you have to create the Docker account. So you have to do it on the hubdocker.com. So let me open docker.com. So this is an environment of Docker, and if you want to sign up, you have to get started and sign in over there. Sign up over there. I'm already signed in, hopefully. So I have to use my my finger. So don't take my finger away. And I have a couple images over here, so you can kind of see them. This is my registry. It's public. Anyone can just download it. And that's an environment. So when you sign in, you have to use these credentials. And they are going to be used over here. So that's one of the things that comes with this system, and we are going to use it. So so now, so we have to go to this directory, and let me explain what we have over here in this directory. So you are a Devops engineer, and you get this environment from the GitHub, and your developer is saying, "Oh, this is your application. Use it. Everything is done for you." So you have a couple of files over here, but most important file is Docker, and you have this server.js, which is the application that runs, and everything is tied through Docker file. You will see the Docker file is important over here. So let me go to our instructions. So first of all, we will build it. When you are going to build it, you will see some of the instructions in the Docker file. You will see that we are going to use Node server. So every language is has different environments. So you have to find your image, but images for JavaScript, server-side JavaScript is called Node. So you would download Node, and it's in version 10. Probably you would like to, for example, download the Kitura server or Python Torch or Java Open Liberty. You would use different source images, and you can find it in our next example. Then we are going to use some working directory. We are going to copy package. We are going to copy remaining files. And finally, we are going to expose our port, which is 8080. And then at the end, after exposing the port, we'll start the application node and with the server.js as the application. So so that's going to build our image, and we are going to use it. There's an also option that you can download. You can use the GitHub repository, and you can compile image or build the image from the GitHub. I'm not going to do it. I'm going to use existing directory. So I have to be in this directory. So let me just copy it over. I have to be in this directory where I am. So so I am in my my desktop, dub code and data Docker. So this is where I downloaded the application. If you downloaded it, probably is in downloads. If you unzip it, you would have this Docker Node.js and language service. I also added this data because there was in a step in the recipe, there was this data instruction. So I'm going to paste this instruction, and you see I have to replace, this is important step, don't forget about that. You have to replace your Docker name with your Docker name. In my case, my Docker name is Blue Marek S. It's with K. So you have to log into the Docker. If I remember correctly, it's just a Docker login, and you provide the name and the password, and it hooks you up to the environment. You have to do it at least once, I think, in the beginning. You might have problems with that if you don't do it. So I'm building the environment. So let's see what's going to happen. So you remember I told you there is a node 10. So it's using the image node 10. Probably in your case, it's going to download this image. I'm using existing because I did it at least a dozen times. It's setting up an environment over here as well, showing up the working directory, copying package JSON, run npm install, so to set up the environment for the node. So getting the latest, greatest versions, and then copy environment, exposing port 8080 over here, and then running the server. So that's the and it created our image. It calls it Blue Marek S /node -container, and it's latest because I didn't specify any name. You can also specify some tag, and a lot of people are doing that. So that's the thing that it's done there. So so we have done that. This is some explanation what is happening, and now we are going to run this this command over here. One of the things that you have to fill out is a Docker name. So once more, I'm putting my I will be putting my name. So Docker user Blue Marek S over here. But also you have to put these elements that we copied before from Watson service. So you can either click over here and you can copy it, or you can just drag and drop an entire command. So I will clear it, so it's you will see more. And so this is entire command. And first of all, I'm going to change the name of of our image. So it's a Blue Marek S, blue without E. And then we have to change two things. So API key, let me go first over there. I'm going to change API key. And I have API key. So this is the API key starting with W, capital W. In my case, your case, it might be completely different. This is just the key, the API key. So I'm pasting it over here. So it's pasted. And now I'm going to replace the API URL. It's going to be replaced in this quotes over here. So I'm going to copy this entire code except from quote to quote. I don't want to have double quotes. I just want to have single quotes over here. So we have in quotes this command, and hopefully it's going to start. I had some challenges just before this workshop. So I wrote a lot of information how to do it and what to avoid. And this is this long number. This long number is ID of your container, and this container is supposed to run on port 8080, and how we can connect to it. So we have this Docker run, and we done it. Now we can curl it, and we should see some output. And I had some challenges before, so you can go also to see log. But let's curl it. So curl is another command. If you don't have it, you have to install this command in your system. It's going to heat the system with this this local host. So it's on local machine with this to our microservice that we created in this application. So it's a small application. Let me open our environment. So we are going to curl our port 8080. So this port where we are running our container. Maybe it's going to work. So what is happening, our application, it worked. Our curl command is hitting the to HTTP request port 8080, asking for translation of this text, and our microservice that is listening on this port is connecting to the cloud. So on our local machine, is connecting from our local machines to the cloud, asking for the translation, receiving JSON with the answer, and providing us with the translation. So we have the translation back. If it works fine, you don't need to do anything. I had a lot of challenges this afternoon, so I had to publish the pull request, so change, because it didn't work for me. I was furious. Like 2 hours ago, I was trying to go through these examples, and I had to go through this command. So if you want to see the logs, you can just go docker logs. So you can write docker logs, and you can just copy the name of this. You have to copy the name, but with the space, not like logs. And it will provide you docker logs A. So docker logs. So this is the output of the logs. So everything worked. So there is no problem. I had some issues. So even I copied information failed to connect to localhost, connection refused, and I drill it down. But we don't have this problem. So now we can change it a little bit, and you can change it to your language. There are some languages that are supported, not all of them. So so you can read more about the service on the documentation of the service. So the easiest way is to let me just open this here. So here, so you can have German, but I can use also my Polish. Since I'm from Poland, I can tell you if it's okay. So jak się masz? Nobody says jak się masz in Poland, but that's a direct translation of how are you. So that's kind of one of the tests. Maybe you remember Greta Thunberg, who was saying this sentence that a lot of people are suffering, people are dying, and so on. So we have this this curl over here. You can see how it works in various languages. So again, in Polish, it would go like this, very quick. We can also change it to let's say Italian. Okay, this is in Italian, and so on and so on. So you can translate languages. And that's the end of the exercise. So let me see. There's not the end of the exercise because we have to clean the system. So we have to stop the container. So so this is the command you can use for our name of container. So if we clear it, so it's Docker PS. So all the services that are run under the Docker, and we are grabbing all the names with node container. So so that's our environment. This is the name. So we can now go and say Docker container, and we can say stop, and we can provide this name. So that's our name. As you notice, this is then part of the name, the first couple characters of the name of our service. I don't recollect how many, but you can kind of count it yourself. And it will tell us, okay, it stopped for some time, hopefully. And now you can also say, please remove this container. It's removed. And now you can say, you can also look for the images. So Docker images. So I can show you how many images I have, plenty of them. So so one of the images we are using today is, they are big and small. So which one is, so also you can use this grep. It was node. So we have couple node containers. And this is one we want to remove. Node is the version that that I was using today. We can remove also this one. I don't use it maybe. So you can go and say Docker image and NRM, and you can delete it. So it's, I think, this one. So let me just copy it over, and it will scream at you that you are deleting something that is inappropriate to delete if it's being used by container that is already out there. So that's one thing. Let me see if it's we did stop. We remove container. We got the Docker image. We remove the image, and that's it. You have some logs that you can train it on the Docker, and you can use it. So congratulations, that was your first step with the in adventure with the containers. So stop sharing. So do we have some questions? I don't see some questions. Everything is recorded, so you can backtrace whatever I was doing. So so that's one of the ways to contribute and participate. So let me share the screen again, and we will drop to the presentation again. So this is our labs. And we are not going to use them at the moment. We are going to our presentation window. We did this presentation over here. So everything is super cool. And you have just one container, and it's easy. You develop your startup idea. It's a translation service, or maybe it's a chatbot for COVID-19, and you are just super happy. Some people are hitting this service. You add version for Italy, for China, for US, for West Coast, for East Coast, and suddenly you realize you have to handle a couple of them. It's not just one. You have each per geo. So one in UK, one in EU, so European Union in Frankfurt, one in London, one in East Coast, one on the West Coast. You have one in Asia Pacific, and all these services, you start to handle. Still, you can do it. If you're a startup, you have 5 people usually, or 4. These are the people who are creating the new thing that's going to change the world. So it's very easy to manage. You are just one developer doing IT. There is one salesman, one legal person, one developer, and one marketing guy. So you have like a small group of people, and you are just responsible for this these 5 containers, and they are asking you, can you provide us with the new version? Can you upload the new version? And now suddenly, just managing these 5 servers, 5 containers, all across all those regions becomes like a small headache. But it becomes a super cool stuff, because in a COVID-19, you get a lot of people who are interested in this. A lot of people are really dying and really needing your service. So suddenly you have clusters of those, and you are overwhelmed with the task. You cannot sleep. So a lot of people are facing this type of the problem. I mean, the problem of this too large success. Is it application to do the chatbot and information about COVID-19, or maybe Zoom that we are using today is having like too many people using it, or maybe it's a Fortnite, a game for a lot of kids that are joining the servers. Suddenly you have the problem, and this problem is a problem, a headache for a long time already. And there were a lot of systems that were on this layer 5 of a container ecosystem, and one of them is Marathon. There is Mesos. There is Docker Swarm. So if you have just dozen of those containers, you would probably be okay with just running a Docker Swarm. But a lot of people started to use Kubernetes, and over the last 2 years, Kubernetes got the biggest share of the market. So because of that, we promote and we talk about Kubernetes. And what are the Kubernetes? It's an orchestrator. So services are coming, you upgrade the services, you allow the new release. You can manage your applications, but that's very important. You do not manage your machine. So vendor is providing you with the environment, on which you deploy your Kubernetes clusters, and you do not manage your machines. They are being managed for you by somebody else. So you have to kind of manage it. You get the managed Kubernetes, for example. So Kubernetes are also designed for extensibility, so you can add new things to it to improve the functionality. And the beauty of it is that it was donated by Google to Linux Foundation, so a lot of people are contributing to it. So it's super super useful now. So Kubernetes, they are having some architecture that you have to be aware of. We did today. We created an image we put inside the container, and that was end of our story. In a Kubernetes world, now this container that we have created is an application A. So application A now lands in a pod that has some networking table and has some basic storage, and that's the unit that you would design and use in a Kubernetes ecosystem. You would always ask for the pod. You would never mention the container. Container would be a part of the pod specification. And in this ecosystem, you have a node. So node is the physical element of your infrastructure. So on the node, today we have created for you 3 nodes for each of the participants. In each node, you have 4 CPUs. So this is the node is the kind of physical virtual machine for you. Not virtual machine, it's a machine, it's a node that is dedicated to your environment with dedicated CPUs, so processors and RAM. So in our case, it's 4 CPUs, 4 virtual CPUs, and 16 gigabyte of RAM. So you have some environment, really like a desktop machine that is available for you. And you have 3 such machines available for you, and 3 nodes otherwise speaking, or calling them. These nodes or these applications in a pod, in the pod, they are communicating with the outside world through the service. I removed the link under application B service just to give you information that sometimes you want to have the service just internal for the cluster. So it could be a database that is not being seen from outside. So you would you access the service from application A, I mean, application A can reach the service B, which is, for example, some other service that is just internal for our internal purposes. So that's more or less the setup. And application A is using internal Ingress system, so it's a load balancing system that allows us to distribute the load between pods. So what you can do, imagine you know what's going to happen every week. You have a huge workload during the weekend. For example, you would bring up the services during the given time, and you would scale it up. You can also have some healthcare. You can have a health check testing, so you can see what is happening with the service, and if it's not responding, you would restart it by yourself. You can also design servers by size. You can say these are small, medium, and large installation, and you can then use it very, very easily and deploy the applications there. Also, you have service discovery, so you can call the service by kind of name, and you have load balancing, so you can distribute service through, for example, this Ingress I was mentioning before. And when you have a new version of the application, so your developers brought new version, you deploy it, and this version is not performing, so you have rollback. You don't deploy it, and always you try to check health check to do the health check. If it's bringing up, it doesn't bring up, so it will stop and it will wait for the rollback. And when you roll out good version, it will replace the old containers step by step if the health check is met. And finally, you can deploy the secrets, so nobody would know about secrets that you are using in the environment. So imagine you have created a solution for one customer, and they are using this this environment. Now you want to move it to the next customer, and there is a lot of things you have to remember to copy, and everything is based on the YAML files, and it's with 100 containers and services, it might be overwhelming. So people came up with the Helm, and Helm chart provides you with the information how to deploy containers and services in Kubernetes. So just a hint for that. So now we are coming up to new thing. Kubernetes is the setup that is that involves a lot of technologies. Usually you use Kubernetes together with, let's say, intelligent load balancing, which is called Istio. And Red Hat before was curating distribution of one of the Linuxes. So Red Hat was working with the CentOS and turn it to enterprise version of CentOS, which is called Red Hat Enterprise Linux. And the same they are doing with Kubernetes. So they package and curated together a couple technologies. They are open sourcing this technology and calling this OKD, or Origin Community Distribution of Kubernetes. So it's a version of Kubernetes with some goodies inside, and it's being curated. And you can buy this license. So if you're a bank, 500 Forbes 500 company, maybe you would like to have a maintained version of Kubernetes, because when I was working as an architect for banks on behalf of IBM, or I was working for other companies and dealing with the large government and financial institutions, they always wanted to have, this support. They believed in Linux, but they wanted to have a support for Linux. So they were choosing Red Hat. I was always fighting with Red Hat myself, because I wanted these companies to buy either HP Unix or buy AIX from IBM, or even go to mainframe. And they were saying, no, we are going to use Red Hat Enterprise Linux, because Linux is open source. So the same is over here. You would use this Kubernetes, but it's maintained. You have subscription, and you feel safe because Red Hat organization is taking care of it. So that's kind of comparison. There are some other things that usually I try to bring up. So I will go over. There is a small presentation by my colleague Sai Venan. You can watch it. I might have a link somewhere in my documentation for that. But there are a couple of differences. So Kubernetes versus OpenShift. And as I said, Kubernetes is a part of open source environment where you have Kubernetes and you have community addition of various technologies together. So you have Kubernetes, you have Docker, you have Istio, and so on, some couple other technologies. And these technologies are a source and an element, or maybe not source, but the package, curated package and maintained package by Red Hat, and Red Hat is packaging it and providing to you as the OpenShift as a product. When you deploy application, when you come with the Kubernetes, so your first step is write the code, create the Docker image, put the Docker image in the registry, and now from the registry you create your story in CI/CD. So you create the Devops pipeline that's going to build the project. When you deploy it with Red Hat OpenShift, you just create the project and you deploy it. It's very simple, and that's one of the parts that OpenShift or Red Hat is trying to do: simplify entire process. When you manage, so you have an installation, you want to manage it with Kubernetes. Some installations are not having too big of UI. But you like to have a UI, you would like to manage it. You have Elk, which is the stack for log and searching through your log, and Istio to manage manage your deployment. In OpenShift, where your project is having a nice UI, you have a very similar stack. It's called EFK, and everything is managed for you. So that's one thing. Security in terms of OpenShift is very strong in Red Hat, and in Kubernetes you have to enforce it through a couple steps. So role-based access control. You have to use IAM services that are available through most of the clouds. On IBM Cloud you have it. You have to use authorization services. On side of the Red Hat OpenShift, you have the project. You have basic and very ground-based security features and constraints that are helping you out to keep the project safe for the future. And also in extending your environment, when you want to use Kubernetes, there is some ways to extend your cluster. With OpenShift, you use Ansible, and it's very simple. So these are the kind of comparison. What you choose is up to you, but I will give you a try on the next slide. I have been interviewed by Nigra Boy, who is MongoDB developer advocate. He has his podcast, but you can listen to this podcast through this link. And I am speaking about that for almost 2 hours. So we have a conversation, and we are trying to kind of go over this. And if you feel that this presentation is going in the right direction, but not enough information for you, you can listen to it once more. And this podcast is super cool, and I welcome you to listen to it. I will copy this link to the chat in a minute. So let's use pre-provisioned clusters, and I will check the presentation if you have guys any questions. So I don't see questions. Let me first copy over this link over here. So just a moment. So first podcast, if you want to listen to it, go ahead and save it for later. There are two documents. It's my article that leads to the two podcasts. And now let me share next step. So we are going to use again. Let me share the screen again. So it's last 10 minutes of the presentation because it's super simple. So we are going to use clusters that are pre-provided for you, so we will be able to access them. The only thing that you need to know, you have to get this IBM Cloud ID, which is the one that you sign up to IBM Cloud. So without that, you won't be able to do it. And the ID is this link, link to clusters. I'm going to copy it over to our presentation over here. Where is this over here? So I have to stop share to paste it over here. So this is a link to our clusters, pre-provisioned clusters, and the password is in the presentation, but I think it's also available in the link. So this is the password you will use, OS Lab. So let me now share the screen again, just a second. And so the presentation. So next steps, command line interface is one thing that you can use for some of the labs. You can use the small window over here. And when you log into IBM Cloud, you have this small cloud shell, so it will open the cloud shell. For some of the users, like I'm macOS user now, it will block you. It will tell you, oh, I cannot open it. So you have to go to Safari, for example, if you use Safari, settings for this website, and you have to say, okay, you can stop media with sound or allow pop-ups. So you have to get these things set up. So just letting you know that it might be difficult. And one of the things I will show you later on, how you can sign up for to access your cluster later on. But we are not going to do it now. So we are here. And now let's let me get back to our. So this is one of the things that you might need. I showed you how you can also use your local environment. So if you have a Docker, you can use it on in your terminal. But we are ready to start the labs right away. I told you about our architecture. So our architecture is very similar to what I showed you before. So we are having 3 nodes, 1, 2, 3. And in those nodes, you will be able to deploy your projects, which is the pods. And we will base everything on the pods. And this is the link that we can use. You have also access to this Git book. I gave it to you. It's one of the links over there. So I will not look into it now, but this is the pre-provisioned cluster. So I will click this link, open a new tab, and over here, if you look in the presentation, where is my presentation? It's here. So if you look in the not in presentation, I wanted to say something else. If you look in your documentation in the Git book, you will see OS Lab. So this is your password, OS Lab. In my case, my spell checker always is changing it to slab. So just keep it in mind. And my name is Marek Think. This is my fake account I created on my my startup page. So robotics inventions. And everything is correct. I agree to the terms and conditions, and I submit. So for me, it might not work because I claimed one of the clusters before, but it worked, fortunately. So my cluster is number 9. And what's next? So what's next? Let me see. We have seen this, and if anything wrong happens, let me know. We have this chat, so please let me know. I have access to all the clusters. My colleague gave me the driving seat. Also, we have the access if you guys sign into Slack. We have dub code Slack channel that Paola shared with us, so so you can use it. But I have the lab over here, and we have this. These are the clusters. So I sign up now, and I can see who signed up at this moment. So we can kind of watch it. I will just refresh the. So these are the clusters. Some of them are deployed with the problems. I have number 9. So this one is okay. But if you guys by chance hit one of those that or get to one of those that are with problems, let me know. So as soon as the cluster is, as I will check it out soon. So one of the things we have to do. So so now we are ready. If you get the assignment, if you see the screen, you can go to the next slide. So so this is one of the steps that you can do. We don't need to do it because these are the prerequisites. I will show you how to do it. So they are asking us to clone the version over here. So you can clone it. I will not do it now. I will skip this step because we just need to access our cluster, and this is on the step 3. So what do we need to do? I will just copy this step over here to our chat window. We have chat window over here. Chat. Yes, I have it. So this is the step I'm going to use. And let me show you how to do it. So first of all, let me recheck our situation over here. So I am signed up. There is one more person over here assigned to server 24. We have 24 hours to at least to use those servers. So it's so we have some time to do it. We can also check it later. If you guys have any problems, let me know. But first step, let me go back over here. So this is my free account. In free account, you have my account, and if you click, you should see this other account over here. If you don't see it after logging in, let me know. But this account is the other environment in which you won't have these services, but you will have cluster. And I have two clusters. One I tried earlier, and now I see also this one. So I'm going to use this guy over here. And now I have, this is the view you would see. If everything is normal, this is UI of Kubernetes, of managed Kubernetes on IBM Cloud, but this environment hosts, in this case, OpenShift, so Red Hat OpenShift. So when you click this, there's some question. We are almost done, so so I will just show it very quickly. So so when you open this OpenShift web console, it should open for you the environment. And this is how the environment looks like. So it's UI, UI in which you can create projects. I will increase the size. Let me move this window. It's from Zoom window. And I will go over the steps of the lab. So that's not the thing I want to show. This is not the thing I want to show. I had this. So we will prerequisites. So we did this step number 3, access to OpenShift Cloud. We can click on the OpenShift on the side as well. I didn't show that, but you would see these clusters over here. You would see this view, and then you would open the web window, and you can copy your login command. So this is one of the things that you can do when you go to the more advanced labs. So I can close this. So this is your environment in which you would work, but this is wrong environment. So I have to close it, and you have to, if you want to use your OpenShift Web Console, you have to change the environment not to Marek's account or your account, but you have to use the IBM assigned environment and click this button, and then your environment starts in a moment. But over here in the UI of OpenShift, you would see this little button over here, and you have the copy login command. You have to copy it over. And then in this environment, when session starts, you have to copy this command over here, and it will assign you to this cluster. So now you will be set up with the cluster, and this is an environment, and you can play it further. We don't need this. I just wanted to show you if you have any problems, so you can go back to this recording and do it. So so now let us get back to our labs. So we did this. We went through this. We copied the command. We logged in, and we are ready to rock and roll. But in the lab number 2 that we are going to run, we have created the OpenShift console is opened, and now we are going to create the service. So let me open the console. So create project. This is the place we want to create the new project. I will call it workshop, and you can add some other names, but I will just create the project. And And now we have to look for view all. So you will see. I need to call my son because our guinea pig is on the loose. So we will deploy the image. I'm very afraid because it's going to eat my internet. And we are going to use the image over here. So so the step before I selected the image, I pasted the element over here. So so let me. It's not here. It's over here. So we click over here. Now we have to paste this name in the image. So what we are going to do. We are getting the in this window over here. We are selecting image and we are looking for the image from outside. And we are getting the image over here. I'm looking to the side because my guinea pig, my son's guinea pig, is getting away, and now I'm just deploying it. So so when it's done, you can go to the project overview, and you see the pod is starting. So while it's starting, I will try to catch the guinea pig, and you can catch the guinea pig with me. So our guinea pig is running away over here. You see, guinea pig is running away. Hey, guinea pig. Run away, run away. The guinea pig is very angry, so probably very, so now it's locked for some time. Hopefully I will put some stuff over here. It's not going to run away. If it's going to bother us, we will have some more fun. So you have seen a guinea pig of my son. It's called Fluff because it's very fluffy. So when the pod is active, you see now it's changed the color from gray to blue. It makes it's available. So now you can. Oh, somebody's commenting on my guinea pig. Hello, hi Fluffy. Yeah, yeah, Fluffy is super cool. I must say, I wasn't fortunate to have any pets, but it's good for kids. We have also a hamster. But it's in other, and it has other names. So now we have to create the route for external traffic. So if someone wants to go and check your application, you create an app, and you see everything is set up for you. It takes all the information from description from this app and from this image. So we are going to create this, and everything is set up for us. So route to authors successfully created, and so this is what we have done. I try to put all the information for you, so you can backtrace me, and you can do it even after this workshop. And now we are going to click on this link, and we are going to add open API/UI at the end. So it will open open UI for us, and we'll have the application there. So let me just go over here. So this is the application. I'm clicking it over here. So I didn't. So it's Open Liberty. It's Java server. It's Java application. So I'm adding Open API, and I'm adding UI. So it opened very quickly for us. You see, this is the server, and we have the application, and now you can check if it works. So so we can kind of try it out. You can click Get, and this is how you would interact with the service. So you can try it out, and it will respond with the name, Twitter, and blog. So it's done by my colleague from Germany, Niklas Heindorf, and we can look for this unique author over here. So if we execute, it should give us the response, and his handle in the Twitter is nheindorf, and so I'm looking here. Fluffy is back in the cage, so so I'm safe. Internet is safe, so we can continue. And so application is working. So that's the easiest way how you can access your application. You create your application. So somebody's created the application for you. You just install it on on the cluster, and it works. So that's the easy way. On this, I will finish. I will look for the questions. You can also go with the various deployments. I just want to give you a heads up. So this is the stretch goal application from the, you would build your application and from GitHub. So from the place we started. We have also next steps showing applications with Minishift. So it's for version 3 of the OpenShift. They are also for version 4. We are using CRC, and these workshops are coming. You can see entire workshop over here, so you can kind of follow it up. We'll update it over the time, so you will be able to go through various labs and you can test them out. So if you lose the access to OpenShift on clusters of IBM, so the paid clusters, you can move to your own machine, and provided you have enough RAM, you can kind of run it, and you need just a good developer platform to work with your environment. So now let me see if we have some questions. We have hi Flav. Flav is back to his terrarium, so this guy is good. So we can go back to the presentation, and we are almost done with everything. So sharing again, and so I have just a couple slides. I showed you where to find this we have 3 more labs in Minishift, which is version 3 of OpenShift. But for your local environment, you can do exercises with Node-RED, which is the no-code environment. There are some questions. Let me see. Yes, I will share the PowerPoint with you guys. So so no headache with that. It will be available through this. If it's not already provided through this Git book, so it should be there. So conclusions. Red Hat OpenShift on IBM Cloud is the managed version of OpenShift, and you can access it and use it for production environments. There's also managed Kubernetes, and I try to explain to you what is the difference between Kubernetes and OpenShift. So OpenShift is a managed, curated stack of Kubernetes and other technologies like Istio, packaged together and maintained and provided for customers to make it even simpler to use and with less resources. There are Minishift workshops and CRC workshops coming soon. So if you don't have access to OpenShift today, you can use it on desktop for free and learn it. One more thing that I wanted to add, IBM is running for the 3rd time call for code, and we are trying to cover 2 things. One is COVID-19 and helping as developers, we can help others, and we are trying to give the prize to the best solutions that are coming to help us to cope with the pandemic. Also, we try to talk and discuss the climate change and climate crisis. So we want to also address if you have idea and you want to contribute and make your knowledge, make your development worth for everybody, you can contribute to the cause. And so if you go for this link, ibm.b/call4code, you can contribute and you can work with other developers and create we are working together with the United Nations, and last year we had couple other companies that were participating in it. So it's the 3rd year we are doing this. It started just on last Sunday on 22nd, and the submission time is till July 31st, so till summer. And in October we will announce the winners. Last year we had the winners from Spain. They created project IoT or wearable project Prometeo. And 2 years ago, there was Project Owl. It was ad hoc network that was deployed already in Puerto Rico after hurricane. It was very cool solution. You can read more on our site. And the winners are getting the attention from the VCs. We are promoting them to VCs. We are giving them $200,000 of price to make the project into product and deploy it globally. And in addition to that, as I said, I'm based in San Francisco, and you can follow us on the on our meetup page, which is shown over here. We have another online meetup, Journey to Kubernetes Security, so more advanced subject on March 31st in the early morning, 9:30 a.m. Pacific. And on April 1st, we have another lab, interactive lab, with building blockchain apps with JavaScript. And it's also online. Just go to this meetup page of IBM Developer SF Bay Area Meetup. So on that, I am ready to finish. So I will just check out if there are any questions. If you don't have questions now, but they are come up later on, feel free to join us on Slack. So we have Slack channel. Let me show it to you how it looks like, so you can kind of start to participate. So let me share the screen once more. It's not easy to navigate through all these windows, but I am coping, I think, with the little body over there. So this is my Slack channel. We are in general channel, and my son is getting nervous. He wants to start to play games, I think. But we have some channel over here, so so you can kind of see everything, and that's our way to communicate. You can direct message me, and I will be more than happy to respond to you. So so if I don't see any questions online or so, I would like to thank you very much. And Paula, would you like to add something?
Yes, thank you, Marek. Someone asked if you're gonna share the PowerPoint. Although yes, and so thank you, Marek. And also we're gonna share the presentation that is being recorded. So probably we're gonna send it or post it in the meetup event tomorrow.
All right. So thank you very much. Have a good night, and thank you very much for watching. For those who are watching the recording, I really appreciate to be here. I hope that we can meet next time as well. And good luck with containers. I hope that everybody got some information about that. So talk to you later. Bye bye.
Thank you, Marek. Bye bye.